Logics. In the previous class we have discussed about the AND gate in gate level modeling. Okay, so we have discussed about the AND gate in gate level modeling, and also we have discussed about the TB to write for the AND gate in the gate level model. Today in this class we are going to discuss about AND gate in Dataflow model. Okay, so without any delay, let's move into the today's topic, that is AND gate in Dataflow model. Okay, Dataflow modeling. So the TB will always be same. Okay, if you are going to watch my previous videos, I always told you, right, the TB will be always same, only the design part will be changed for this levels of abstraction. Okay, so if you are going to change the module name in the design code, then you need to change the instance of that particular module which you have instantiated in the test bench with that particular name. For example, if I am going to change the module name of our design to and underscore gate data flow, then you need to use this name, use this instance name, and you need to change it over here. You need to give data flow. That's the only change. If you have made in design code, then you need to made it in test bench as well. Otherwise there is no need of any changing the names. There is no need of changing the TB. Okay, yeah, so that's all about the TB. This TB, how did I discussed in the previous video. Okay, in the gate level model I have discussed each line. Okay, how we are going to write the TB, I have discussed in detail in the previous video. If you haven't watched that video, I recommend you guys to watch the video to know about how to write the test bench for this particular AND gate. Okay, so today in this class what I'm going to do is I'm going to discuss about the data flow model, right? So the port list will be always same. Okay, the port list will be always same for any levels of abstraction that you are going to write. Okay, only the matter in between the semicolon and the end module will be changed according to the levels of abstraction that you have chosen to write. Okay, since we have chosen data flow modeling right now, so we need to use the assign keyword while writing the code in data flow model. Okay, so that I am going to use the assign, and then we are going to use the Boolean expression for particular logic. Okay, we need to know about the Boolean expression. For example, here our output is y, then y equal to, and the operation that here we required is and operation, so that that is in between a and b, right? In between two variables, those are a and b, right? So this is the symbol for the bitwise AND operation, and then semicolon. Okay, this is how we are going to write the code for the data flow modeling. Okay, this is how we are going to write the code for the data flow modeling for the AND gate. Okay, so let me save the code and run the code for you. So I am going to save the code. Before saving the code, you must select the tools and simulators. Okay, before executing the code, what you guys need to do is you need to select the tools and simulators. In that I am going to select the tool which is first one, like this. You need to select it, and then you just save the code. There should be no star mark over here. Okay, save the code and then run the code. So I am going to run the code. So you can see the output of the code. Okay, so at 10 nanoseconds time instant, you are going to get, we have applied the a equal to 0 and b equal to 0, and we have chopped y is equal to 0. After 10 nanoseconds point of time, from 10 nanoseconds point of time, which is at 20 nanoseconds point of time, we have changed our inputs from a equal to 0 to, we are leaving our input from a equal to 0 to a equal to 0, and then we are going to change our input from b equal to 0 to b equal to 1, and we are going to observe output y is equal to 0. Okay, so similarly we are going to see for the next case as well. For the last case, which is a is equal to 1 and b is equal to 1, we are going to get the output y is equal to 1. Okay, it means when both the inputs or all the inputs to the gate are 1, we are going to get the output as 1, so that we can able to say that this is the functionality or the truth table of AND gate. Okay, since we have verified, right, so we can able to say that this design code is the function is giving the functionality of the AND gate. So for example, if you want to see the output in terms of waveform, then what you guys need to do is you just select the open EP wave after run. Okay, here you just select the open EP wave after run, and then you guys what you need to do is you just save the code and rerun it. Automatically the waveform will be pop up, will be shown to you, will be pop up to you. Okay, so you can see the output a, b, I and y. I is nothing but it is an iterator variable. It is used in the TB. If you don't want this, you can simply delete it by just clicking on it. Okay, and then you can able to see the output. Okay, initially both the inputs are 0 and we are going to get the output as 0, and after that both the inputs are 0 and 1, and then we are going to get the output as 0. After that we have applied the inputs as on 0, and then we are going to get the output as 0. For the last case, that is 1, when we are going to get the output as 1. Okay, so this is how we are going to verify the waveform. You also need to verify the timings. Okay, at what particular time, how does this particular input changes, and at that point of time instant, what is our output. You need to observe this as well. Okay, timing is also most important in case of programming. Okay, these things I have discussed clearly, how to analyze the waveform and also how to write the test bench for our design in the previous class, when I have discussed about the gate level model of AND gate. Okay, so not only using this particular Boolean expression, you can also use the ternary operator as well. Ternary operator is nothing but it is going to contain 3 operands and 2 operators. Those are three operands it is going to contain, and also it is going to have 3 operands or 3 conditions. Okay, it is going to contain 3 operands or 3 conditions and 2 operators. It is nothing but it is nothing but the minimization of if else. Okay, ternary operator is nothing but the it is an alternative for the if else. If else takes 2 to 3 lines, whereas ternary operators just takes only single line. Okay, so let me write the code for you in using the ternary operator. Okay, so I am going to specify the condition in between the braces. A equal to okay, let me specify the condition for you. A equal to 1, and then logical and I am going to use the logical and operation, and then b is equal to 1. Okay, logical and is having lower precedence than equality operator. Okay, this is the equality operator, right? I have used equality operator 2 times and one logical and operation. Okay, this is one condition and this is another condition, and I have combined both the condition with the help of the logical and operation. First, it is going to check whether this condition is true or not. It means it is going to check the value of a and it is going to compare it with 1. If 1 equal to 1, then it is going to result 1 over here, right? So, and then later it is going to check whether b is equal to 1 or not. Okay, these two operations will going to perform at the same time. Checking of a equal to 1 and then b is equal to 1 is going to perform at the same time. Why? Because both are equality operators and both are having same precedence. Okay, both the operations will took at the same time and result either true or false based on the values that we are going to apply, right? After that, we have used the logical AND operation, right? So it is going to perform the logical AND operation on the results that we got from these 2 individual conditions which we have joined with the help of the logical AND, right? Okay, we are going to get the output, and you may have a doubt why I have taken only a is equal to 1 and b is equal to 1. Why not a is equal to 0 and b is equal to 0, or why not a is equal to 0 and b is equal to 1, and remaining other 3 cases why haven't took? The reason behind it, because only for the case a is equal to 1 and b is equal to 1, we are going to have a unique output, that is y is equal to 1. For all other cases, we are going to have the same output which is 0, right? Okay, if you would like to take this condition, if you would like to put this condition in the braces, then you shouldn't just put this condition. You should put this condition, and also you should put all other conditions for which you are going to get output 0, right? But if you are going to see the last condition, only for the last condition we are going to get the output as 1. So that it is better to take the condition which is having a unique output. Okay, unique output, that is also for only single test cases. Okay, test case is nothing but the inputs. Okay, you shouldn't call them as test cases in case of TB. Okay, okay, now we have checked the condition, right? We have checked the conditions. If you are going to put something in parentheses, and if we are going to have some operands, then it is nothing but a condition. We are going to check the condition. This condition can have two values, either it may be true or either it may be false. Okay, overall this condition can be true, again overall this condition can be true, or it can be false. Initially this condition will be checked, both a equal to 1 and b equal to 1 will be checked at the same time. After that, with the help of this particular logical and another condition will be checked, right? Again it can be result to true or false, right? Based on those true or false operation, we can uh, perform two different operations based on the result. Okay, so I'm going to put this question mark, put the question mark, and if this condition which is specified in the braces is true, then what are the statements that you are going to provide after the question mark needed to be executed. Okay, for a equal to 1 and b is equal to 1, what is the required result that we need to get? We need to get the 1, right? Why? Because for a is equal to 1 and b is equal to 1, we are going to get the output as 1, right? If this condition is true, what I have told you, after question mark, what are the statements or the values that we are going to assign? Those particular values will be assigned to the LHS. LHS is nothing but output, right? So I am going to put 1 over here, and then you need to use the colon. After colon, what is the value that you are going to specify, or the what are the statement that you are going to specify? Those things will be executed when this condition is false, and this condition which is specified in the braces are false. So 0. Okay, when a is equal to 1 and b is equal to 1, if this condition is true, then you assign a value, you just pass the value 1 to the 1 through the y. Okay, you just pass the value 1 through the y. If a is equal to 1 and b is equal to 1, is if this condition is true, if this condition is false, then you pass the value 0 through the output y. That's the meaning of this particular line. Okay, so let me save the code, and again let me show you the output, whether this particular code is giving the functionality of the AND gate or not. Okay, save the code and run it, and you just see the output in the console. Okay, I'm not going to show you the output in the waveform. Why? Because it's better to see the output in the console. Okay, you can see the output, right? So this is also the same operation of the AND gate. So this is how we are going to see the we are going to write the code for the AND gate in Dataflow model. Okay, we have so many ways to write. Okay, thank you guys. I recommend you guys to also have an hands-on experience, just simply watching this video and leaving from the session. Instead of that, you can use this split screen, and also you can able to have an hands-on experience. Okay, this is the another way of writing the test bench. Okay, there I have discussed total 2 ways of writing the test bench. Okay, one is I have discussed it in not gate. Okay, I think in not gate first video I have discussed how to write the TB. Yeah, again I have discussed in NAND gate as well. Okay, in NAND gate as well I have discussed the same procedure, how to write the TB, which I have discussed in the NOT gate. This is another method we can able to write like this as well. We can able to write the TB like this as well. Okay, so I recommend you guys to watch that particular video if you want to learn about the test bench, each line, why we are going to write like this. Okay, how we are going to write like this, how to remember all these, what are the steps involved in writing the test bench. Okay, I have discussed very clearly. I recommend you guys to watch those videos. Thank you guys, have a nice day.